that you validate this. So of course, before you do a full-fledged validation, we highly recommend doing something called a profile validation. So what is a profile? Well, a profile in a very simple terms would be the different statistics and the profile of the dataset itself. This includes things that I'm showcasing right now, which are everything from the data type to the count, the exact volume that you see, the minimum and maximum values within the dataset, the averages, the minimum and maximum lengths, the number of missing values, basically the null percentages, and the other aggregates such as sum and averages. So the way we actually do this is we first define a profile and we see if the profiles are directly matching. So now that I've defined what a profile is, let's go back and see what's happening at a broader scale. My data flow, what you'll see, has sources, processors, and data quality nodes. Starts with a basic pulling of profile from Snowflake. I go to properties, you'll see my data set here is my Snowflake data set, and my query is just a dim customer pulling from a particular data set. My application comes with an inbuilt query builder as well as parameterizations and other aspects, and the columns are being filled in right here. Of course, I can choose which profile sets I want to define before the results are made right here. A similar thing is done for my data set from SQL Server. As you see, data set here is from SQL Server. Again, a query is being pulled in, and I can just drag and drop these tables as I will in a few minutes. And the columns showcase the corresponding profiling, and the results are right here. Finally, when we actually look at the actual run, let me just go to profile and show how this works. You first define the data sets you would like to compare. Now here, these are the profiles of the data sets that we are comparing. The mapping window automatically maps the corresponding data sets based on fuzzy logic. So if you have a couple of columns right here, address line 1 and address line _1, the application understands that and tries to match it accordingly. If there are complex changes, you can actually go in and change the corresponding column type yourself or upload a file as well. I'll showcase that in the data flow system. And finally, just to round this particular profile compare out, we see that the status here has failed. This doesn't imply that the component has failed. It implies that the test case has failed, implying that out of the 212 corresponding aggregates, we have found failures of multiple. It basically implies that there are specific cases where there's a difference between the source and target. A quick example here would be that we see that the distinct number of geography keys between our system are slightly different. And of course, you can actually get in and define what your thresholding could be for these specific data sets. And that is in your allowed variance. Since our allowed variance is 0, even a 0.01% of variance is being marked as a test case failure. So far what we have done is that we have picked up two data sets and we have tried to match their profile, and we see there's a failure. Well, that's pretty obvious that we might find some failures. And so let's dig deeper into it. Let's go to the next aspect. And for this, I'm going to move into data flows to illustrate the other aspects. So once again, we are in data flows, and this is our Spark engine. The application comes with both engines, and the only reason we're illustrating both is for different use cases, you might have to do either or, and that's why I would like to showcase both. So the very first thing that we would like to do is actually run a metadata compare. Because if you think about it, the sheer amount of metadata changes on an architectural level between SQL Server and Snowflake are inherently vast. And this is not just between SQL Server and Snowflake. If you're transferring things from Oracle to Snowflake or between Oracle and Databricks itself, there are inherent data type changes, and there's a need for inherent data type mapping present. Because in some data sets you might have, or some architectures, you might have precision decimals, and in others you just might have float. And that inherently is going to cause a difference between your data sets. So let's first ensure that we do a metadata compare. So how do we do that in the application? Well, I go to properties, I select the data sources that I showcased earlier, and I select the schema I would like to work with. Here my source and targets are right here. Of course, this can be interchanged as well. This is just one or the other. And then in objects, I just drag and drop the corresponding objects that I would like to work with. So let me just find another dimensional table for now. So here we have multiple dimensional tables. I'll drag and drop dimension scenario. You'll see that div scenario has already been found in the target object as well. Again, our main aspect here is that we don't want our users to manually go in and do a lot of stuff. If something can be automated, we try our level best to automate it. So in this particular fashion, multiple tables can be selected at once and defined, and the corresponding target objects are usually found automatically. If not, a user can go in and try to find them specifically here as well. I've already run a lot of these flows in lieu of saving time, and with the result of this particular test case is also failure. We see that there's a failure between the metadata, and if I see that points out which exact aspects are failed. The first thing that I see is there are columns within my DIM customer which are not present in my source, implying that within Snowflake these columns are absent, and within SQL Server, sorry, the other way around, these columns are present. That implies that there are a few column mismatches are going to be present. There are column length mismatches. This is particularly important when you're working with string columns. An easy example here would be address. As you might imagine, some addresses could change, and inherent auto trimming might reduce or might limit the number of characters that a particular column might have. So your column length is actually pretty important in this case. And finally, the key important would be the data type mismatch as well. We see DIM customer is the problem child here because we see that it also has a corresponding data type mismatch. So that is metadata compare.
For further questions, feel free to reach contact@datagaps.com. Request a free demo, scan the QR code below. Thank you.